Alright, I said in the last video I was going to do this projected down on paper. Well, it wasn't coming out too good like that, the lights and so forth, so I'm just going to write small on the board. Alright, so the last example here for section 5.8 is find the average value of this function y is equal to f of x, this graph right here, on the interval from 0 to 10. So I want to find the average value of this function from 0 to 10 right here. Well, I know that the average value, f(a)(b)(e) is equal to 1 over b minus a times the integral from a to b of f of x dx. I learned that in the last video. Problem is, I don't have the function f of x. I have a drawing of it, right? So I need to come up with the function f of x. Now it's going to be very difficult to come up with a function if it's not piecewise. So let's come up with a piecewise defined function. So first, let's find this piece of my function. That piece is just linear, so that should be easy. So my first goal is to write f of x as a piecewise defined function, okay? So first of all, we're going to look at this first piece. And what are the x values it covers? From 0 to what? 3. So I'm going to have for x values between 0 and 3, okay? I'm going to use that piece. Now let's see. How do I find this function right here? Well, what is that's linear, right? So it's going to be y is equal to mx plus b. Well, I know what b is. B is where it crosses the y-axis, right? Where does that happen? -3. So I need m next. How do I find m? Well, rise over run, right? If you're going from the point 0, -3, up to 3, how many are rising? You're rising 3, and then 3 more, 6. So m will be 6 over, how many do you run to go from 0 to 3? 3, so that's what? 2? So the first piece of my function is y is equal to 2x minus 3. I already have the f of x. So I need to put in is equal to what? 2x minus 3. And let me actually bring this closer. And that's where what? X is between 0 and 3, we said, right? Including. How about my next piece? That's going to be a horizontal line at a y value of 3. So isn't the equation y is equal to 3? So f of x will be equal to 3. And where does that happen? Between x values of 3 and 5, right? So I'm going to say between x values of 3 and 5. Now I'm not going to include an equal here because we have an equal to 3 and we use that piece there, okay? But I am going to equal to 5 here. All right, let's come up with an equation for this line right here. Now, I'm not going to be able to use this as easy, y is equal to mx plus b, because I don't know what the y-intercept is. But what I can do is calculate the slope by using these 2 points, 5, 3, and 7, -3. Or I could use 5, 3, and 6, 0. 5, 3, and 6, 0. So what's my slope? M will be change in y, so 0 minus 3. Over change in x's. 6 minus 5. So what does that give me? -3 over 1 or -3, right? So now I have the slope and I have at least 1 point. Actually I have 3 here. So I can use point slope form. Y minus y subscript of 0 is equal to m times x minus x subscript of 0. Now I'm going to use this point. It's going to be easier. So y minus a y value in that point is y minus 0 is equal to m, which we said was -3, times x minus 6. So what does this give me? Y is equal to -3x plus 18. So f of x is equal to -3x -3x plus 18 for which x values between 5 and what? 7, right? When x is between 5 and 7. All right, now what's left is this last little part right there, okay? That last little line that goes through the point 10, 1 and 7, negative 3, okay? You can do the same thing you just did for this last one. And if we do that, I'm not going to bore y'all with that for a video, okay? You'll have enough length of videos to watch. But you'll get 4/3 x minus 37 over 3 for that last piece right here. And where's that valid? For x values between 7 and 10. For x values between 7 and 10. All right, so let's see. For my average value, if I go back here, I found my function. Now let's compute the average value. So 1 over b minus a, that'll be 10 minus 0. 10 minus 0 of the integral from 0 to 10 of f of x, right? Well, that's 1/10, but yet to integrate this, what do I need to do? To integrate this part right here, I'm going to need to split it up first of all with the integral from 0 to 3, and use that piece. Then split it up as the integral from 3 to 5, then the integral from 5 to 7, then from 7 to 10. So let's do so. I'm going to, instead of going from 0 to 10 here, I'm going to go from 0 to 3 first of all, plus the integral from what? 3 to 5 next. 3 to 5 next. Plus the integral from what to what next? 5 to 7. Boy, let me make sure I'm on the screen still and I'm not just writing down stuff that y'all can't even see. Okay, good. Plus the integral from what to what? 7 to 10. And then I'm going to close it off at the end. All right, the integral from 0 to 3, I'm going to use 2x minus 3. 2x minus 3 is my integrand. Be sure you put your dx in there. Let me adjust this plus sign. Put it there. How about from 3 to 5? Which piece am I going to use? 3? That's going to be an easy one to integrate. How about from 5 to 7? We have negative 3x plus 18 dx. And how about from 7 to 10? We're going to use 4/3 x minus 37 thirds dx, right? And then we integrate each part and evaluate it and so forth. Oh, I'm going to have to erase some stuff to do so. Let's see. So if I keep going here, let me erase all this actually. So we'll need to all right, so we got 1/10 bracket, and then let's take an antiderivative here. That's what? X squared minus 3x, and we're going to evaluate that one from what to what? 0 to 3, plus the antiderivative of 3 is just 3x. We're going to evaluate that from what to what? 3 to 5. Can I see this top portion on my video? Yeah, okay. Plus, let's integrate this part. So it's negative 3/2 x squared, negative 3/2 x squared, plus 18x, plus 18x. And where are we going from? 5 to 7. From 5 to 7. I don't know what it is about this position right here that makes my marker not want to write. Plus, let's take the integral here. What is that? 4/3 x squared over 2. Or how could I rewrite that? Well, let's just do it that way. 4/3 x squared over 2 minus 37 thirds times x from what to what? 7 to 10, right? From 7 to 10. Close that off. All right, so be sure, like those of y'all going on to Calc 2 or whatever next semester, especially if you're taking a face-to-face class and you're taking testing class and so forth, be sure you show this next part, and then after the next part, your teacher will probably let you use your calculator to finish this off, okay? So that's 3 squared minus 3 times 3 minus 0 squared minus 3 times 0, right? Oh, I don't want to do that. Don't want to close you off. Plus, evaluate this one at 5 and subtract it, evaluate it at 3. So 3 times 5 minus 3 times 3. Plus, I'm right here now. So negative 3 halves times 7 squared plus 18 times 7 minus negative 3 halves times 5 squared plus 18 times 5 plus, now can we call this 2 over 3? 2 over 3 x squared, so it'll be 10 squared minus 37 thirds times 10 minus this stuff evaluated at 7. So that's what? 2 thirds, and a 3 better, times 7 squared minus 37 thirds times 7. And then close your bracket. All right, now if you put all this in your calculator and calculate